awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Alright, example number 2. So let's read the question first. So here we have a drunken motorist who is moving at constant velocity of 90 km per hour. Alright, so passes a stationary police patrol car. The patrol car immediately gives a chase at a constant acceleration and catches up with the motorist after a distance of 10 km. Okay, so first of all, I think we need to change first the velocity. Alright, 90 km. So let's write here 90 km per hour. I want to change to meter per second. Okay, so remember kilometer at the top of the fraction. So the partner should be at the bottom of the fraction. Kilometer, you want to change to meter. Alright. And then, tanya diri awak, 1 kilometer is equal to 10 power of 3 meter. Okay, so for kilometer, we can cancel. And then we can continue to convert hour. 1 hour, alright, equal to 3,600 second. Okay, sama macam tadi, we can cancel hour. And finally, alright, press your calculator. So you... Okay, 90 km per hour is equal to 25, okay? 25 meter per second. Okay, and then let's try to answer question A. Okay, so calculate the time taken by the petrol car to catch up with the motorist. Okay, so before we start, I think I want to draw. Okay, so this is the road, and let's say this is the motorist. Okay, and then it is moving in this direction where u is equal to 25 meter per second. And then here we have a car, the police car here, where the police car, so I will put UP is equal to 0 meter per second. Okay, so here I will put UM, which is the initial velocity of the motorist. Alright, and then as we know that the police car immediately give a chase at a constant acceleration and catch up with the motorist after a distance of 10 km. So let's say this is the point, which is after 10 km. So we call this point as a catch-up point. Alright, and S is equal to 10 km. I think I should convert to meter, which is 10,000 meter. Okay, so for question A, we want to calculate what is the time taken by the police car to catch up with the motorist. Okay, so let's say motorist dia akan gerak sampai sini lah. Kat sini contohnya. Okay, I will put this as point B and this is as point A. Point A here and this is point B. Oops, sorry. Okay, so we want to calculate what is the time taken from A to B. Sebab dia nak masa for the police car, petrol car to catch up with the motorist. Berapa masa yang diambil from point A to point B? Iaitu sejauh 10,000 meter. So, let's use equation S equal to UT plus half AT squared. Since the motorist is moving at constant velocity, that means the acceleration of the motorist is equal to 0 meter per second squared. So, I will cancel this out, which is equal to 0. So now look at here, the motorist will move here with constant velocity. Okay, maknanya masih dia jalan daripada A ke B. Okay, dia still moving with the constant velocity. That's why the acceleration is equal to 0. So now kita nak consider A to B. Kenapa? Sebab kita nak tahu masa police car catch the motorist. Okay, so S should be 10,000, okay, 10,000 is equal to u should be the velocity, okay, the initial velocity of the motorist 25 and t. So the answer should be 400 seconds. Okay, so this is the answer for A. And then B, calculate the acceleration of the petrol car. So the motion of the car is from point A to point B, okay, and it's moving for a distance of 10,000 meter, and the initial velocity of the car is 0. Okay, since we already know that from A to B, okay, the time taken for the car to catch the motorist is around 400 seconds. So now we can calculate what is the acceleration of this police car, okay, when it tried to catch the motorist. Okay, so t is equal to 400 seconds. Okay, u is the initial velocity of the police car, which is 0 meter per second. And s is the distance travel, 10,000 meter. So let's say I will use this equation. Okay, so as u is equal to 0, so this one should be 0. So 10,000 is equal to half. We want to find what is A, and the time taken to travel from A to B is 400 squared. Okay, so finally the acceleration of the police car is equal to 0.125 meter per second squared. Okay, so this is the final answer for B. And then the last question, okay, question C, look at here. Calculate the velocity of the petrol car when it catches up with the motorist. Okay, so we want to find what is the velocity, okay, of the police car at point B. Okay, so this is very simple since we already know that the acceleration A and also the time taken. So we can straightly use this equation since we want to find the final velocity of the police car at point B. So V is equal to U is the initial velocity of the car, which is 0, plus A is the acceleration, and T is time taken to travel from A to B, okay, which is 400. Therefore, the value of the final velocity of the police car at point B is equal to 50 meter per second. Okay, so this is final answer for C. So now we finish example 2. So let's proceed to example number 3. Alright, so example number 3. So here we have an object initially at rest, move in the positive x direction at a uniform acceleration of 2 meter per second squared until it reached a velocity of 8 meter per second. And then what happened? The object then traveled at a constant velocity of 8 meter per second for the next 3 seconds. Finally, the object decelerated uniformly at 4 meter per second squared to stop. And the first one, we want to calculate what is the total time for the whole journey for the object. Okay? So before we start, okay, I think I want to sketch first. Let's say this is the starting point. We call it as point A. Alright? And then this is point B. So initially, the object is at rest. Alright? So means that UA is equal to 0. And what happened? Okay? The object is moving with acceleration of 2 meter per second squared until it reached point B, where velocity at point B is 8 meter per second. Okay, so the acceleration is given 2 meter per second squared. And then for the next 3 seconds, okay, masa untuk TAB ni kita tak tahulah berapa. Kita tak tahu. Okay, but from point B to point C, okay, the object is moving with constant velocity. Kalau dekat point B equal to 8 meter per second, means that velocity at point C also 8 meter per second. That's why when the object is moving with constant velocity, the acceleration at this point is equal to 0. Okay? And it's moving from B to C, the object is moving for 3 seconds. Alright? And then finally, the object decelerated uniformly, okay? From C to D, the object decelerated, okay? Maknanya velocity dia berkurang lah, decelerate. A is equal to negative 4 meter per second squared. Negative is very important in this case because the object is decelerate. Okay? And how long? From C to D? Okay, kita tak tahu berapa. Okay, but we know that at point D, the velocity is 0 since the object will stop at point D. Okay, so ini maklumat yang kita ada lah. So for question 1, so we want to find what is the total time for the whole journey. Means that we want to find T is equal to TAB plus TBC plus TCD. TBC kita dah ada 3 second, but TAB we need to find first. TAB, okay? Okay, so we can use equation from A to B lah. Gunakan maklumat A to B. Okay. So we can use VB kita dah ada. V is equal to U plus AT. So VB is equal to 8. U is equal to 0. Acceleration is given 2. This time we can find T where T is equal to 4 seconds. This one is TAB. Finish that one. And then TCD, okay, which is from C to D. Okay, so let's highlight first. And then for this part, I will use the same equation. Since we already know that at point D, the velocity is 0, U at point C is equal to 8. Sebab dia daripada point C ke point D. Plus, this time, the object is decelerating so that A must be negative 4. T. And T is equal to 2 seconds. And this is TCD. Therefore, okay, sorry, I will write here. Okay, therefore, T, the time for the whole journey should be TAB 4 seconds plus TBC 3 seconds plus TCD which is 2 seconds. And the total answer is equal to 9 seconds. Okay, so this is the answer for number 1. Okay, the total time T. And then number 2, sketch and label the velocity time graph for the whole journey of the object. So we want to sketch V against T graph. Okay, make sure you put the unit first. And then this is time T in seconds. 0. So kita tengok kita punya time interval from 0 A ke B adalah 4 seconds. Let's say kita letak kat sini 4. And then from B to C is 3. So 4 plus 3 should be 7. And then from C to D, okay, the object is moving for another 2 seconds. So 7 plus 2 should be 9. Okay, so the velocity is equal to that one, V yang kita dah kira tadi, yang kita ada 8, kosong tu je lah 2. Okay, so now from 0 to 4 second, the object is accelerating. Sebab dia meningkat daripada 0 hingga 8 meter per second. Okay, so you boleh buat straight line graph lah. Okay, you buat cantik-cantik. Sekejap macam tu lebih kurang lah. Okay, ini from A to B. Okay, and then from B to C, it's moving with constant velocity. Okay, at 8 meter per second. Okay, selama 3 second. Okay, from B to C. And then from C to D, the object is decelerating. So the acceleration should be negative. So like this, from B to C, and this is D. Okay, so finish that part. Okay, and the last one, question number 3. Okay, so calculate the total displacement. So remember the total displacement, okay, is equal to area under the graph. And remember, okay, this is the area of the graph V against T. And look at this area, okay, berada pada positive ataupun above positive x-axis. Means that the object is still moving in positive x direction. Maknanya dia bergerak ke depan. Tak ada pun V kita negatif. V kita semua berada pada positif. Means that the object is moving to the right or to the positive direction. Okay. So, we can straightly calculate what is the total displacement. Okay. This is the area of the trapezium. Half times the height of the trapezium, which is 8, times the parallel side of the trapezium. Okay, the parallel side is BC, which is 3, plus A to D, which is 9. 3 plus 9. Guna formula trapezium. Okay, and then finally the answer is 48. Okay, so this is the answer for question number 3. So now let's proceed to question number 4. Alright, question number 4. So let's read the question. So a car is moving with velocity of 90 km per hour along a straight road. Upon seeing the traffic light turns red, the driver applies the brakes and slows with an acceleration of 16.5 meter per second squared. How far does the car move before it stops? Okay, so now let's say this is the road and this is the traffic light. Okay, so this is the traffic light. And this is the car that is moving from here with the initial velocity of 90 km per hour. Make sure you know how to change to meter per second, which is equal to 25 meter per second. Okay, so it's moving from somewhere here. Ni daripada sini lah. Okay, suddenly, let's say at this point, okay, brake is applied. Okay, dia tengah bergerak daripada sini tadi. Okay, and then dia nampak traffic light at this point. Yang warna merah ni tadi, brake is applied. Okay, so what happened? Slowly, okay, the object will reduce its velocity and the object will decelerate with deceleration of, okay, soalan dah bagi negative 16.5. Okay, sebab dia decelerate, so negative. Okay, sekarang dia tanya how far does the car move before it stop. So dekat sini kereta tu akan berhenti. Kita consider dia berhenti dekat sini. Tapi sebelum dia berhenti, berapa jauhkah dia travel? Okay, yang saya highlight dengan warna biru ini. Okay, so kita nak kira lah berapa dia punya S ini. Boleh? So number 1. So, since we already know that V equal to 0, U of the car is 25 meter per second, acceleration pun dah ada. So, saya rasa kita boleh guna formula yang ini. Okay, V squared 0, U is 25 squared plus 2. Okay, A must be negative 16.5. This is very important. Boleh? And then S. Okay. Therefore, S you akan dapat nilainya adalah 18.94 meter. Okay, finish that one. And then question number 2. How long? That's mean we need to calculate the time taken for the car to stop. Okay, so we can use this equation since we have the unknown of the time, which is T. Okay, V0 U25 plus negative 16.5 T. So, the time taken for the car to stop daripada point dia apply brake tadi sampai dekat sini lah kita consider macam tu. Okay, so T masa yang diambil adalah 1.52 second. Okay, maknanya dia tak langgar lah traffic light tu, dia berhenti sebelum traffic light tadi. Okay, so finish example number 4. So, let's proceed to the last example. Alright, example number 5. So, let's read the question. So the velocity of a clown truck, which is decelerates uniformly from 50 meter per second to 10 meter per second within a distance of 60 meter. Okay. So macam biasa saya suka tulis point A and then point B. So what happened at point A, the velocity is 50 meter per second. But the velocity is decreasing. They decelerate uniformly, okay, which is at this point V is 10 meter per second. Bila dia decelerate, kita tak tahu berapa nilai A dia lah. Tapi sebab dia decelerate, we consider in positive direction. So it must be negative value. And then the distance, again, from A to B, it is 60 meter. Okay, macam tu. 60 meter. Okay. So, and then, ada lagi tak? Okay, tak ada. Okay, A. Okay, calculate the deceleration of the truck. So, kita nak kira, okay, nilai A dia lah. So, dekat point B, kita dah tahu. So, kita boleh tulis lah, VB squared equal to UA at point A squared plus 2AS. Okay, so this one we can substitute all the values straightly here. Okay, so A kita nak cari, as we have 60 meter, therefore the acceleration is negative 20 meter per second squared. Unit jangan salah tulis. Okay, unit paling penting sekali, jangan salah tulis. Okay, so this is the answer. And then for B, okay, finish A. The time taken for the velocity of the truck to decrease from 50 meter per second to 10 meter per second. That's mean from A to B. What is the time taken? This is very simple. We can use equation yang ada time. Okay? Which is V equal to U plus AT. So V is 10, U is 50. Acceleration is negative 20 T. Therefore, T is equal to 2 seconds. Okay? So we finish question B. And then for question C, the time taken, okay, for the truck to decrease, the time taken for the truck to stop from velocity of 10 meter per second. Kalau saya lukis, that's mean kita nak kira time taken from B to somewhere here lah, kita namakan dia C. Where at this point, the car will stop. Okay? So, kita nak kira lah berapa masa yang diambil. Dia minta daripada B, daripada dia punya velocity dia 10 sampai kosong. Okay? Dan because case ini dia decelerate uniformly, maknanya yang kita kira acceleration tadi dekat sini, A equal to negative 20 meter per second squared. That's mean A yang dekat sini pun sama. Acceleration dia akan jadi negative 20 meter per second squared. Okay? So, bila sama, kita boleh teruslah guna formula. Kita nak kira T kan. So, VC equal to U. Sebab kita kira mula daripada point B. So, UB lah. Okay. Plus AT. Acceleration dia sama. Okay. Decelerate uniformly daripada point A ke point B and then ke point C. So, VC, the stop. And then UB, 10 meter per second plus deceleration is negative 20 T. Therefore, T is equal to, this is time taken from B to C, which is 0.5 seconds. Okay, so finish that one. Very simple, right? Okay, and then for question D. Okay, D, the extra distance traveled by the truck before it stops. Okay, actually we want to find what is the extra distance. Kalau daripada A ke B, soalan dah bagi 60 meter. So, kita nak kira yang warna hijau inilah from B to C. What is the extra what is the extra distance traveled by the truck before it stops? Okay. So, kita boleh guna formula yang ada S lah. Maknanya V daripada B ke C kan. So, V ini mesti VC squared equal to, okay, U mesti daripada point B plus 2AS. Okay, so this one should be 0. This one should be 10, 10 squared. Deceleration is negative 20S. So, daripada ini kita boleh nampak lah. From B to C, okay, the answer is 2.5 meter. Okay, 2.5 meter. Betul tak? Okay, so kita boleh kira lah kat situ. Okay, so kalau saya kira 10 squared, which is 100, divide, one is 40. Okay, 2.5. Okay, so finish that one. And finally, the last part, okay, E. Sketch a velocity time graph based on the question above. So, we want to we want to sketch V, this one meter per second, and T in second. Okay, so kita nak kira lah. Kita dah kira dah sebenarnya. So, kita kena tahulah from A to B, masa yang diambil adalah 2 seconds. Okay, saya letak 2 kat sini. And then from B to C, dia nak stop kan? So, dia nak stop. So, tambah lagi 0.5 second. So, ini contohnya 2.5 seconds lah. Macam tu. Kita tahu from A to B, 2 seconds. And then from B to C, it takes about 0.5 second. That's mean here 2.5. Okay. And then the the velocity, it starts with 50 meter. And then it will decrease to 10. And then the last one, 0. Okay. So, from A to B, the object will start at this point. Yang saya color merah ni lah. Lepas tu dia decelerate uniformly. Dia mesti straight line lah. Okay, straight line. Okay, sampai 2 ini. Macam tu, you ambil pembaris, you buat straight line. Okay. And then what happen? From 2 to 2.5, okay, dia decelerate lagi. Maknanya dia straight line sampai bawah. Okay. You ambil pembaris, you boleh buat straight line sampai bawah macam tu. Alright, so now finish subtopic 2.2. So for the next video, we will try to discuss subtopic 2.3. Okay, and I think I will upload again about projectile motion. Okay, the short notes animation. Okay, but this time for the projectile motion for this session 2022-2023. Okay, we just focus on projectile motion that projected an object at certain angle of theta and also projected an object horizontally. Okay, so no free fall equation will be discussed in next video, which is subtopic 2.3. But we just focus on the projectile motion for 2 cases. Alright, so thank you for your support. So see you in the next video. Assalamualaikum. Bye-bye.